Hi, welcome everyone. Welcome everyone to the IP Location Services and Automated Biometric Recognition Forum, the second Public Interest Technology Colloquium in association with the IEEE Society on Social Implications of Technology. I'm absolutely delighted to see a number of people here just joining this platform. I think we have a couple more people coming in, but just great to see the interest. I would like to thank first and foremost the Society on the Social Implications of Technology and the Society of Policy and Engineering Collective. Us being here is really a testimony to the increasing awareness of the choice we can make around the design of our technologies. And I think this is an absolutely great opportunity to have this discussion. My name is Salah Hamdoun. I am your moderator today. I am personally very much involved in the public interest technology in IEEE. I'm a third-year PhD student at the School for the Future of Innovation and Society. And my research really focuses on financial technology and society, and particularly around the individual freedoms and restrictions. So this discussion is very close to my interest. Today we have an exciting program for you all. In short, in a short while we'll have Dr. Katina Michael will have a briefly introduce the event and our first speaker, James Winterbottom, excuse me. We'll hear from Dr. Eusebio Scornavaca about the possible business applications of location-based services, and Dr. Katina Michael on the ethical implications of location-based services. We will then move on to 2 or 3 breakout rooms that are facilitated by my dear colleagues, Martin and Farah, who I'll introduce to you in a little bit. Once we come back, we'll have a group presentation about the case studies that we had discussed in the breakout rooms. Excuse me. And absolutely last but not least, we'll listen to Satija, excuse me if I spelled it correctly, but before closing for a short discussion on the next steps. I'm honored to give the floor now to Dr. Katina Michael.
Thank you so much, Salah. It's great to have everyone here present. This is an important topic that we're covering today. I want to introduce to you 3 people that will help us through today. That's our MC Salah Hamdoun from the IGD program, Martin Perez Comiso from our Human and Social Dimensions of Science and Technology program, and Farah Naja Arivalo from also the Innovation in Global Development program, the IGD. It's my honor to actually introduce James Winterbottom today, predominantly because I've known James since 1996, and we shared some amazing adventures back at Northern Networks for at least a period of 6 years while I was there, and thereafter he went on for many more years. He's also the author of IP Location Services, and that book was co-written with the late Martin Dawson and also the other Martin Thompson. IP Location came out, I would say, about 2 decades ahead of its time. James and the late Martin Dawson were very much steeped in emergency services at the time, looking at how location services could be used for good. And I said to the team before we began the call today that while the creation of standards and through the IETF and other avenues, the ITU, the creation of the GeoPriv standard and so much more under development that Martin and James were part of, were very much revolutionary at the time. The late Martin Dawson spent many years in the US on 911, and a lot of the FEMA work that was being done in emergency services and emergency management back in 1996 to 98 or 99, if my memory fades, James will correct me. But there are videos online from guest lectures that James gave when I was at the University of Wollongong, and also Martin gave on push and pull services, on commercial services, on the way Retail organizations were using IP location, whether you could look at spoofing or not, and so much more. But really, we have an expert here on next generation emergency solutions from Deveryware that's committed to better security, which is music to my ears, because if you're going to offer IP-based technologies, they need to be secure. And the other thing that gets me from James's bio is the emphasis on equivalent access for people with disabilities. And I emphasize that in the public interest because we're always harping on about those who haven't got access or equivalent access or universal service, and how service providers are constantly letting down individuals on universal service obligations. And when we're talking PIT, it doesn't get more inspiring than this. So over to you, James, and I thank you for your time, given how busy you are with Europe at the moment.
So a little bit about me, and it looks like we've got Jerry Eisner in the call, so he'll keep me very, very honest. Jerry and I go back quite a long ways too. So as Katina said, my start in emergency services started with the cellular space back in around about 2000. Where the FCC had passed some legislation or regulation in the United States, which required mobile phones to be able to provide, or mobile operators to be able to provide accurate location information for 911 services. And then went on from there because voice over IP was becoming a big thing to have a pretty lead role in the development of the US I2 solution, which kind of worked from how you deliver calls from the new IP space into the legacy PSAP space, and then on from there into IP to IP space and legacy into IP space as things moved on from there, and then moved into the European space, which is similar but different to the United States. So let's just start off with a little bit about Deveryware. Which is the next slide, Katina, if we can jump to that. Right. So Deveryware is an all French-owned company. It's a private company. It started in about 2003. Profits grown basically 1,000% over the last 12 years to 37 million euros a year. We've got about 140 staff across parts of Spain and mostly based in Paris. We do quite a lot of work with the French government, particularly around geolocation and security. So we've got a very big cybersecurity group based in Paris. We spend 10% of our revenue back into R&D, and we also do a large number of collaborative projects with the European Commission, amongst others. So we've got about 18 of those collaborative projects going on at the moment. And as Katina said, we've got a very strong focus on cybersecurity. The group that I'm associated with is purely focused on the emergency service aspect and what kinds of technologies and services we can provide in that space. So next slide. So I'll give you a little bit of history in terms of the rise of the app, because basically we all use them now. Since about the early 1900s, the app of choice for communications was the telephone, as we might all be familiar. It was an app, but it was a device and a network all in one. And it really didn't change at all until the 1990s. Okay, we went to touch tone dialing and we didn't have to call operators in so often, but basically the general interface and the general device didn't change for the best part of 90 years. And then we had the mobile phone come along, kind of the late 90s, and that was a little bit slow in its pickup, but then it really hit critical mass, and we ended up with the situations, oh, well, that telephone number doesn't help us with telling where the person is anymore, where before the telephone number was, your actual private number within a region, and then you had a region and you had a country and so on. And when that happened, we really started down the path towards E911 in the United States. So location routing became important. Location for dispatch became important, because traditionally in those environments, when you had a landline phone, the telephone number was linked to the location by the operator, and that was then provisioned into the various switches that they had, and that was then put, and that location or that address was provisioned against your name inside the public safety answering point, or the PSAP. We also then moved into standards around how that was going to work for cellular with the 3GPP and the 3GPP2 specifications. And we ended up with all these magical location devices, the Gateway Mobile Location Center, the Mobile Positioning Center, and goes on and on and on. And then kind of fairly shortly on the heels of that, we ended up with home internet services. So initially those were dial-up, which were pretty slow for those of us that remember, and they made funny boinging noises when your modem connected. And then wireless data started to come in. And then the next thing you know, we had ubiquitous data everywhere with wireless broadband and fixed broadband. So DSL, hybrid fiber coax for cable, fiber, LTE, 5G, fixed wireless, Wi-Fi, soft phones and VoIP. So the whole dynamic changed once we ended up with reasonable speeds from broadband services. So then we had a few things that came along that were kind of game changers, right? So we had the iPhone that came along, which was arguably the first really smartphone. Everything else up to that point had kind of been a bit clunky. Even our good friend, the BlackBerry, was kind of clunky. It was really a mobile email is the way in which I kind of view it. And we had Android, and then boom, right? So with those smartphones, the app just took over. It exploited all of the device resources. It could do everything. It had microphones in it, had video cameras, it could do location, it had compasses in it, it had gyroscopes in it, you name it, it had it. And the ones today are even more sophisticated, right? Every time you blink, they've got a new type of sensor inside these things. So we ended up with an extremely powerful device that was mobile, that had all of these communication apps on it, and we're using one now. And then you had HTML5, which came out, and WebRTC to make the browsers, and effectively now you've just got the ultimate app. So your browser can support full video conferencing, as more or less we're doing right now. And that rise in apps has led to a fundamental way in which we communicate. So we all used to use the telephone now. How many people actually make a call to one another using a telephone? It's really not common. Oh, okay. One, is that your preferred mechanism? Yeah.
It's me because I raised my hand when you ask.
Yeah.
I prefer it for depth conversation, but not for quick data that my brain can forget. So if it's like a particular piece of data that what time or where, place, or what.
Right.
But
so if you
talk,
needed to communicate a short amount of data very quickly, it wouldn't be your first choice.
Yes.
Right. Okay. Cool. So let's jump to the next slide, because I think I'm probably going over a little bit. So the US really led the way here, right? You've got a highly devolved emergency system in the United States. And my numbers here might be a little inaccurate now. Jerry can probably correct me on that. But you dial 911 in the States, and your very first point of contact is your local PSAP, which is quite often at the county level. It varies a bit from state to state. You know, some states have got state level PSAPs, but by and large, it's very localized. And in Texas, for example, you have community government areas where you've got multiple counties that kind of come together. I said country there, but it really should be county, sorry. So in the US, you've got about 6,000 of these primary PSAPs across the United States. And they're all different, and they all do different things, and a lot of them are still running very legacy, old, trunking gear. But you've got an emergency, you've got a telephone, and you've got a route to the local PSAP. So you've got a pretty serious problem on your hands. And the FCC, as I said before, set mandates for the mobile providers. So by and large, they still do this. They route based on the rough area of the serving cell. So the cell that you're connected to, because they can do that quickly. They can do that with with tables in their routing systems, and that makes it fairly quick. Of course, one of the problems there is that you might not go to the right PSAP. So there's some tuning and things and some handovers that need to occur. But that location's pretty bad. And the further out you go, the worse that location gets, because you might be attached to a big omnicell. So if you take a 3GPP omnicell, for example, that can have a 60-kilometer radius. right? So you look at the area concerned with that, you can be anywhere in that very big search area, which is not great. But the PSAP call taker could ask for extra or more accurate location, which could come along later, which could be based on various data inside or in the device or from the network in terms of timing and those sorts of things. And that gives you significant improvements. So that really led with the E911 stuff. It's not uniform, but it's still better than the rest of the world. A lot better than the rest of the world. So let's have a look at Australia, Europe, and what the rest of them were doing. So despite international cellular standards that have been around since the 2000s, and Martin Dawson worked very closely on a lot of those, at least the early ones, really only the US and Canada did anything with them. And it's not difficult and it's not expensive to roll out. Canada rolled out in less than 12 months to cover the entire country. The US has taken a bit longer. But I think, you know, a sizable chunk has now at least got the E911 stuff deployed. Australia, gosh, what an embarrassment, given that some of the world leading people were here. They invented something called Molly. And Molly basically chopped Australia up into 223 regions, and they used what they called JK digits. So you might know with telephone numbers, you can only dial between 0 and 9. Well, in the signaling, you get up to 0 to 15. So they use those extra digits to represent areas that you're in. And okay, so that would normally be 256, but they used some of those for some other stuff. So you're in there are 223 regions across Australia. So Australia is roughly the same size as the United States. You're in one of them. Good luck being found. We've just moved to cell-based location here to the operators. And when I talk about those kinds of 60-kilometer radius cells here, we've got a lot of those. So we've gone from being not even in class to being worst in class. It's really a bit sad. But we do have an app here. That app was actually built by the emergency services group, I think NetWeek, and it uses the device to provide location, but you're still dependent upon the caller to tell the operator where that call is or where you are. In Europe, mostly cell ID. There's a bit of timing advance thrown in. Now you're starting to see this thing called AML come out, which is built into most of the Android devices now. It was pioneered by a friend of mine in the UK who ran the 911 or the 999 system there, because he just became so desperate that none of the regulators would regulate, and they just would not. So the rest of the world uses cell ID. They convey it in different ways through the system. The US, for example, when they were conveying cell ID, had several different ways of doing that. I'm not going to go into all of those now. We might be able to put on another course that does something about that later if people are interested. Anyway, it's not a really good situation for mobile. Next. Okay, so in Europe, what we had was PSAPs and communities got really frustrated with neither the European Commission nor their member state regulatory organizations making decisions. Each one kind of just blamed the other one and said, you've got to make the decision because it's outside our jurisdiction. And the other one would say, but we need something across all of Europe, and just round and round and round, and it's still going round and round and round. So really what happened was you ended up with quite a few hundred of these very specific apps that came up, which were integrated to push location directly to the local PSAPs. And I think the first time I really saw those was at an ENA conference, and one person to kind of put the point across was they put 4 or 5 countries worth of these apps into their system, and when they're iconified, they all look the same. And if you use the wrong app in the wrong region, your location gets pushed potentially to a completely different country. So it just didn't work. So what came out of that was the notion of the Pan-European Mobile Emergency Application Framework, or PEMEA. And the aim there was to try and bring all of these apps together. So different apps provided different functions for different people. So they were actually demographics within the app space. There was quite a popular hiking app, which could make available to the PSAP the path that the hiker took, for example, because there might be several ways to get there. So they could actually take the same path to find out what sorts of things were going on. There were others that were sending basic medical information because they were targeted at people that had particular conditions. You wanted to be able to send the username and the next of kin, for example, so that you had somewhat equivalent services to what you have today with wireline services. Others had the ability to request AEDs, so your defibrillators, so that you could find the one that was nearest to you if somebody was having a heart attack. But none of them could run. None of them could run. They all had their own dedicated protocols. They all had their mechanisms to be able to talk directly to that PSAP. So PEMEA was really born to address a few of these problems. We needed something that would let apps run. We didn't want to lose the ability of the extensions if some of the PSAPs wanted to support them. So that was fairly key. It needs to be super simple, because if it's difficult to implement, nobody's going to do it and it'll become expensive. And a couple of side things was that we needed to be able, we really wanted to use it as a stepping stone towards NG112, which is very focused on the same architecture as the NG911 in the United States. So we wanted to use the same data formats if we could, so that it became easy then for the PSAPs to be able to move towards that kind of service. And I had a hidden agenda, and I'm sure Jerry knows my feelings on this, was really to avoid a huge number of the pitfalls and failings that we've had in NG112 and NG911. And those pitfalls and failings have led to a very, very slow uptake of NG911 across the United States, despite all the standards work that's been done, and almost a non-existent uptake of NG112 in Europe. And in fact, a number of large member states are in fact actively not adopting that architecture as it stands. PEMEA started in ENA as a 2-document specification, stage 2 kind of requirement spec, and then a stage 3 detailed procedures and protocols specification. And I combined all of those because I wrote that series of specifications over a summer period. And then I combined all of those together into an ETSI specification, which is now published as a European technical specification or technical standard. Next. So a very, very quick overview. On the right is where we'll start. So essentially, the model is really, really simple. You have an application that talks to the notion of this thing called an application provider. And whatever happens over that interface is out of scope for PEMEA. That's whatever you choose to build as an application, somebody that's building an app. It has a couple of functions that are defined, like you've got to be able to pass location up to it. You've got to be able to provide some basic user information, and you've got to be able to say that you want an emergency call, and that's about it, nothing else. The voice call generally went through the mobile operator, or the mobile network operator. And you push this call through to a PSAP provider, which generally provides service to a PSAP. So your basic model that existed before you introduced roaming doesn't change, right? So that PSAP provider is directly associated with the PSAP, and that PIM, that PEMEA interface module, might be well combined with the PSAP service provider as a single entity. And then what I did was I introduced the notion of roaming. So that PSAP service provider can know about the local PSAP boundaries that it supports. It doesn't know about anything else. That's all it has to know about. Do I support this? No. Then I push it out to this thing called an aggregating service provider. And the aggregating service provider kind of operates as a global level, and it simply looks at any of its routing tables and it can pass stuff around. So it knows about other PSPs or other ASPs, and that's it. So in a roaming model, I'm on my app, and I can go to that bottom piece. I'll push through the application down and then across to whichever PSAP it happens to be associated with. So that's the general model. And then we've got 2 other functions that we can do, which is across that magical PC thing at the top. The PC does two things. It, off to the right, Katina, the PC interface, up, 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 there, right. So that does two things. It lets the PSAP tell the application provider that the message has got to a PSAP. And it says, what capabilities that you pushed forward, I can support. Capabilities are defined completely outside PEMEA. It doesn't come into that basic spec, but you're able to say to the PSAP what capabilities you can support. And if there's a direct match between what the PSAP can support, it says, I can support these. We'll get to why that's really useful a little bit later. And that's really it for PEMEA. So once you've got a set of capabilities you can mutually support, the PSAP can then invoke those capabilities as it sees fit. For example, getting location updates, getting the user information, getting the medical data, getting the hiker's path, whichever applications or whichever additional functions are supported by both entities, the PSAP can come and get them whenever they want. Okay, so that looks pretty simple, but scale that out across the whole of Europe, and all of a sudden you've got all of these nodes. How do they know what other nodes are really in the system? So we set up this thing called the PEMEA Registration Authority, where you don't get to connect into this network until you register some stuff with there. You don't get to register some stuff with there till you've passed a conformance testing that says you comply with the basic signaling. Once you do that, you register some things in there. You register a domain name in there. You register the type of node you are, and you register a destination URI and some contact information and other bits and pieces. And that all gets put into this registration authority. And if you are a legal entity, that is, you're allowed to connect into this network, you're actually allowed to pull down a whitelist of all of the other entities. And you go and do that every 24 hours or less. And we can keep track of how many times a particular node is downloaded, so we can send them a message and say, boy, you guys haven't really kept your list up to date very much. And when you've got a small network like we've currently got, it's not so bad. When you get a big network where apps might come in and go out, depending upon whether they merge with others, etc., becomes a problem because you don't want to have bad nodes or nodes with old information. So we can move to make nodes inactive. So that's the role of this PEMEA entity. It manages the overall security of this network. So there aren't very many things that can make changes to that. We're about to scale that up a bit so it becomes, it can be moved off to an independent entity that's going to manage that, whether that's under the EC or under basically a non-PEMEA operator environment, so that there's no conflict in there. 3 messages in PEMEA, only 3. It's really easy. I have an emergency data send message, which each node does, and they just add the fact that it went through them. So I've got a route through the network. Each one of those nodes responds immediately back to the previous node with an EDR. So I've sent this stuff on, and the EDR has the additional routing information in terms of where it went to next. So the next hop. And then you've got an error that says, oops, something went wrong. And that's important because you've generated the route header as you go along, we know where the thing went wrong, and we have a basic reason as to why. And it's really simple. It's HTTPS all the way through TLS 1.2 or 1.3, and you know immediately whether or not you're allowed to send it to the entity because you've got the entity list, and if it's not in the list, you don't send it. And if you don't receive it, if it's not in the entity list as well. Okay, really, really easy. Next. Okay, a little bit about GDPR, because this is the big thing in Europe. GDPR basically says you really don't want to keep private information. If you do keep private information, you better make sure it stays private. And if I don't want you to have it anymore, I have the right to be forgotten. So in this kind of model, you want to send as little private information as you can and keep as little private information as you can. And that applies to emergency services as well, because there are really only 2 edicts here. One is the general and one is the police, and you either are in one or the other. So the general model in GDPR is you've got something called a data controller, which obviously owns the data, and you've got something that processes the data. And so our model basically breaks up into that. You've got a data controller, which is the app and the app end initially, which your app probably has information about your user and things like that. You've got the app provider, which might temporarily hold that information. And in our GDPR statement, because we've got a formal one, we don't store any of that stuff on disk. It's in memory, it's volatile, thing goes down, it's all gone. We've got data processors, which really don't have very much information, except they've got the MSISDN or the identifier of the entity, and they've got the location. They only store the location information, and they only do that so that you've actually got a history of how the route was determined through the network, because these things have got routing engines in them, and it's important to understand if you've got an error in your routing engine or something along those lines. You don't keep any information in that network beyond that, so there's no way to associate that back with an entity. And then obviously you've got the PSAP, which in some member states has got regulatory requirements to keep some of that data at least. I think that's a big grey area with GDPR because they don't call out emergencies centres like that, and GDPR overrides member state regulation. So there are going to be some interesting test cases in there, I think, in the future. The general gist is if you don't have to keep it, don't. And if you do have to keep it, make sure it's really secure. Oh. Are we moving to the next one? Okay, right. So PEMEA is really easy and really fast to implement. We had a European Commission project called Nexus a couple of years ago, well, probably 3 years ago now or 4 years ago. And we decided that we wanted to put PEMEA into that. So the Deveryware Emergency Service group really grew out of this. We went from 0 implementations of PEMEA to 3 interoperable implementations running all of the security stack in 6 weeks. And I think Jerry, who's been involved in all of the plug tests in the NG911 space, very few of those have actually run full security stacks, and they're multiple years in. That consisted of doing geospatial routing. It consisted of support of user information requests and location update requests. 3 months in from there, we had one of the partners in that project with an instant message chat service up and running, and audio video of a WebRTC from an app to a mock PSAP. That's how quickly we went. And they were able to do transfers of those, well, not transfers, but actually bring in third parties into those audio video conferences. So, you know, bring in the fire department, bring in a medical people, whatever you needed to do. By the end of the project, we had 3 interoperable chat implementations. That chat protocol is about to come out as an ETSI spec as TS103756. We had 2 interoperable WebRTC implementations, including third-party linking. We had 3 interoperable PEMEA bootstraps so that we could actually get the NG112 stuff to work from a roaming point of view in a secure fashion. We had every single aspect of the project had some critical or crucial PEMEA component in it in order for it to work properly. The European Community for the Deaf and Hard of Hearing absolutely raved it. They got up at our demonstration to the Commission and said, we want this. Project AIMS, which is the latest one that we're involved in, is introducing public alerting into PEMEA. There are some big advantages to that, particularly if you're roaming around the place, because you can all of a sudden get your alerts in your native language, which might actually mean something to you, as opposed to whatever they happen to come out in. So you can get a much richer view of what the alert is. We're supporting real-time text. We're doing file uploads and sharing, and we're introducing IoT devices like alarms, telehealth sensors, and those sorts of things. Next. And I'm way over time, Katina. I'm very sorry. You were right.
No, you don't apologize, and we are going to hear you right to the end. Thank you.
Okay.
And we'll have you back.
So,
we'll have you back too.
At the moment, the blue areas are live running PEMEA in Europe. The yellow areas, we're expecting to see those come out by the end of this year. So we'll have, well, whilst we've got the whole of Spain covered, I think we'll have 3 or 4 regions in Spain. And one of the big drivers in Spain is disability services. We've got trials going on in Portugal because one of the members of the AIMS project is in Portugal. We've done some in Spain, but we're looking at doing more, sorry, in France, but we're looking at doing more there. Slovenia, who were one of the partners involved in the Nexus project, are now very keen to come on. And then we're looking too at some of the Eastern European countries. So we've got a lot that's looking at this and coming on board. As I said, we've got Finland at the top there. Sweden's currently doing pilots. Sweden, again, are a member of the AIMS consortium. So lots going on, and lots of people want different services. And one I probably can't talk too much about is Romania, which will be online by the end of the year. Okay, next. Right, so we've set up a consortium, which is the PEMEA consortium at www.pemea.help. We've got a number of organizations that are members of that, including universities. So really what these people are about is trying to promote the ease of access to emergency services, and it shouldn't be so hard for everybody. And now if we're using these web technologies, we can get them to be really feature rich, really easy to deploy, and if we do it in the right way, really safe. So these, we're talking now about web emergency services or web ES. That's kind of the thing that we're pushing. You know, we've got the consortium's putting out pre-standard specifications. So things that we can test and modify and make sure that we're really happy with them and then take them into Etsy. We're doing interconnection and operations documents. As I said, we've got industry and academic collaborators in this. We've got an interesting group of third-party service providers that are interested in coming and joining that. So at the moment, these service providers have direct long number calls into a number of PSAPs across Europe, and they take calls directly from motor vehicles or from people that are looking for services just beyond just the core emergency type capabilities. And anything else that's going to provide advanced access to emergency services and services for first responders. Ongoing standards with interoperability extensions. So we've got TS 103.755, which is looking at shared services between PEMEA and NG 112. The core things there are largely around routing and around call queuing. And we're also looking at some of the policy components. The main thing there is that the people that are standing up these services don't want to have multiple provisions for the same service. So they don't want to have to go and put a separate routing database that they configure for PEMEA as opposed to their existing ECRF component that they put in, say, for their NG112 service. Real-time text, that's coming out as being a consortium spec really soon now. It's just a matter of getting it up onto the website, I think. And then we'll be looking at moving that into Etsy as well. And we've got a number of other EC project specs which we'll be putting out, including the WebRTC spec in more detail very soon. James's personal interests. So I've got a number of things here that I'm quite interested in. I'm very interested in things to do with keeping elderly people in homes and keeping them safe. And so being able to give them a service in their home where they can call either a third-party mechanism, which might be associated with some retirement trust, but where they're in their home so they can get the nursing support or the home support they need at a particular time. I'm also interested in if they have a dire need for something, how they can get that quickly, which might also include a video service so that the state of that person can be seen, or the safe transfer, of anything medical that they've got connected to themselves, like pacemakers or whatever it happens to be. So I'm very interested in that component. I'm very interested in general communication application and integration rather into general communication apps rather than having to have dedicated communication apps. I mean, we've all used Skype in the past. I realize that it's not people's flavor of choice at the moment, but it has served us very well in the past. I still use it a reasonable amount. WhatsApp, we've pretty much all used that, I'm sure. Facebook Messenger, FaceTime, the list goes on. Every time you blink, there's a new communication app that comes out. PEMEA is so easy to implement that I actually want them just to put it into that application on their own. You know, there are a number of people that provide APs or application providers that will give you an API. You literally just integrate that API into your solution and push stuff up. It's that simple. So it would be really nice to see those services come on board, and I really want to make it easy for those things to come in and happen. So that's what's happening next. And I think that's probably about it, Katina. There we go. So that's kind of it from a very high level. We didn't go into anything in too much detail. And that's really where we're at.
Thank you so much, James. This is really great. And thank you for your forward-looking work. This is exactly what public interest technology is, envisioning and understanding the various landscapes and realities, right? So do we have time for 1 or 2 questions? Yeah, if anyone wants to raise a question, you can also share it in the chat. If you want to raise a question, you can either speak up or raise your hand in the Zoom function.
Well, my email address, I think, was on the back there, so feel free to send me an email if you're too shy to talk here, or you can send something to Katina and I'm sure she'll pass that on. As I said, we are doing a lot of collaborations and things at the moment. And you know, at some point, I'm sure that we can set up a demo, Katina, and we can sort of show the sorts of things that we can do and how quickly we can do things. You know,
Yes,
I didn't include in there how quickly this thing can be integrated into PSAPs, but you know, we've seen things as short as 6 weeks for basic services. That's how long Finland came on board. So it's fast. Right? That's the key. Is it's fast, it's secure, and it's really easy to implement because it's literally just web APIs. So you can host these things in the cloud if you feel like doing that, or you can host them in your own virtual data center or your own virtual environment. Yeah, they're very easy to do, and once you've got your system in, it'll basically run for free for you.
So James, I have a question regarding a statement you made. You said none of the regulators want to regulate on this issue, despite that it's so important, right? People depend on emergency services and all of these different application types you mentioned. Why? I know there's quite a few people online that actually do regulation or think about regulation or governance. Why don't the regulators want to regulate?
Okay, so please don't take this the wrong way, but my experience with bureaucrats and regulators generally is that nobody got fired for making no decision. People get fired for making unpopular decisions. And there are lots of interest groups, right? So let's not pretend that the carriers haven't got, or the operators haven't got significant interest there. I personally remember going to an organizer, going to a meeting where I had gone in as a vendor, and the previously run state operator was there. And I was told to be quiet because I was an operator, because I was a vendor. And then they turned to the monopolistic state operator, former state operator, who wasn't even a state operator anymore, and said, "How would you do this?" So there's still that, right? Most of these countries had state operated run carriers, and the regulators still defer to them from that point of view. But again, you know, they turn around and say, well, it's going to be really expensive to do whatever, without actually providing a cost analysis on that on the table, and what's the cost of people's lives. In Europe, for example, at least in one of the deployments that we've got going on, one of the reasons that we took a sizable chunk of the functionality for that particular tender and that particular solution is that the carrier turned around and said, we don't plan on supporting video over LTE. What's the business model for that? With the 4G LTE and 5G coming along, the carriers have woken up that they're really just bit pipes for this stuff now. People do make calls over them, but there's no core service or no value add service that they can provide on top of that to the general community. Sure, they provide additional services and things to corporations and to enterprise, but the average caller is going to use them as an internet service provider. That's the reality of the model.
I think we have one more question. Do we have time for one more question?
Yeah. Oh, yes. Yes.
I'll go. James, it was a pleasure listening to you, especially because it's a lot of times when you meet people talking about mobile applications, they start in 2010, and there was the whole decade of some of us that were excited about 2.5G and so forth. I have a question for you. I don't know whether you can comment on this, but especially when you think of emergency services, I've been seeing a lot of issues regarding with algorithm delegation, right? And especially parts of the process of delivery or even interacting with customers. And this morning I sent Katina a sketch from a Brazilian group that was talking about, if you have a murder, press 1, if you're being robbed, press 2. And by the time it gets to the police, well, the guy was well dead. So to what extent you're seeing this trade-off in terms of using AI into emergency services? I don't know whether you can comment on this and the extent to which this can actually be a dangerous choice to automate part of the process, and the extent that is actually being delegated to algorithms to make the decision where and when to dispatch.
That's a really good question. I can't say that into the dispatch space I've had that much experience or any experience. My experience with AI to date is that if you don't train it right, you end up with big problems. Right? It's like a toddler. It takes time to grow up, and once it's grown up, it can be quite useful. But it takes time to grow up, and whilst it's growing up, it can make some pretty catastrophic decisions. So I think the question there, to some extent, is when is it grown up, and how do you decide what sorts of decisions are involved in that kind of thing? Because I suspect if you ask a call taker, they probably go on intuition as much as anything else. So they probably don't actually know their complete decision process, and it would take them some time to sit back and think it all out. I mean, even the scripts that come in for emergency centers, they spend a lot of time and a lot of thought into how they make those scripts so that they're consistent, the operator can learn them relatively quickly, but they help the person at the other end to provide the right degree of information in the right way. I think Jerry's exposure is probably a lot better than mine in terms of how that works, but again, I'm not sure of his depth in the actual inner workings of the PSAP processes.
James, the check's in the mail for all the nice things you've said about me. Thank you very much. Just by way of introduction, my name is Jerry Eisner, Vice President of Public Safety at Red Sky Technologies and Everbridge Company. I've been in the public safety communications space for 37 years. I've probably known James for like 30 of those. When it comes to AI, we're seeing it deployed more, not in the actual call taking, but in incident construction. We're seeing it have a big role in the logging and recording space, where keywords will drive certain types of things. So it's an adjunct more than a primary tool.
So I have heard of, like, at least in the Europe space, one of the things that they're considering looking at is if you're having particularly high call rates for particular locations. So for example, if you've got mass shooters or whatever it is going on, you could direct those if the call rates for those particular areas to an IVR or something along those lines, that if you're reporting this case, hey, we already know about it. But I haven't really heard about using it in much other space. I know some of the projects I've been involved in, they have talked about using it in the initial instance if you've got kind of text-only communications going on, so that you can get a better feel for how that's going to go, you know, to make sure that you end up in the right service in that environment.
The other place where I've seen at least discussions about AI is in language translation.
Yes, well, we use that in our service for the chat or the instant message. It's quite easy to do that, so we support multi-language. Europe, for example, has some quite unique cases that you perhaps don't have quite so much of in the United States, in that you can have cross-border environments where the languages are totally different between them. And your call might go to a PSAP that's in one country and your actual geolocation is in another country. So you've actually got PSAP call takers in one space talking to first responders that are in a different country. So being able to do those automatic language translations is really important. You also have quite a lot of migration in Europe between countries where, and Australia suffers from this too, and I dare say the United States, where you've got you know, the parents of people that have spent a long time in the States coming there towards their retirement time. And so they really don't speak the language very well at all. Being able to have real-time communications that do that kind of translation for them are really helpful. So that's one of the things that we've looked at there. Sign language, for example, is not ubiquitous. There are lots of different variants of that. So all of a sudden, if you can translate that into a typed text language, you can manage that translation very quickly. And in Spain, for example, our primary driver there has been equal access for people with disabilities. It's so bad in Europe in terms of general deployment of support for people with disabilities that it just doesn't bear thinking about. Some countries, Austria and Germany, for example, the standard and preferred mechanism still is fax. So you write it up on a piece of paper, you fax it. I've heard stories in the United States that it can take 20 minutes before you get proper operations happening or calls completing in the States with regards to TTY type services or people with disabilities, because they always go to a third-party service. Jerry's probably, again, more across some of those numbers, but it's atrocious. Like, it's really, really bad. And Europe has a mandate that says you're entitled to equal access. So in Spain, the Community for the Deaf and the Hard of Hearing got together and they said to the central government, you're in breach of the law, fix it. Threatening all sorts of action if they didn't. So you know, really, this community is starting to get its voice, for want of a better term, and quite rightly so. So being able to support them in a real way, which is really easy to do. So there's very little excuse from a public safety point of view, particularly public operator point of view, to not provide those services. You know, that's where we're at. I mean, my view is that this is a public service, and if you don't start providing it as a public service, then private companies will come in and take over that particular role. It will happen.
Hi, everybody, and thanks, James. Really enjoyed the talk. When you were talking about 911, I wasn't thinking of the emergency services. I was thinking more of the event of September 11. And then that got me thinking about doing these sort of systems as a way of doing it offline. So what happens when those cell towers go down? How do the first responders still be able to do what they need to do? And this got me thinking about probably 20 years ago, Katina, at Wollongong, when those firefighters went up into the World Trade Center, they couldn't communicate, 80 floors apart because the connectivity had gone, the cell towers had been destroyed. So have you got any thoughts about what happens if we need to go offline and still have this type of communication system?
So I think that there's still a massive amount of Tetra deployed for first responders, which is not going through the cellular network. Mostly, it's still an independent radio network. And again, Jerry's going to be far more familiar with that than I am. So when you're in that kind of environment, it's going to be much more the environment that's responsible for them not being able to communicate than it is the cell towers going down. Whether that remains the case with things like FirstNet, where they're piggybacking off 4G and 5G cellular spectrum, that may not be the case. I know that the communications that we've put into PEMEA are fairly resilient to at least dropouts and things like that. They're not going to be resilient to extended inability to connect. And I'm not too sure if you're typing up a message or if you're doing something via video, what the benefit of that is going to be if you can't communicate with them in real time. So I guess I'd need to understand a little bit more about the types of services that you're looking at doing a transfer for.
Yeah, I think this was just the basic message of like a traffic light, red, come back out, get out, you know, there's danger above you, something like that. It was more than near field communications. It was probably wireless or more like a LAN type setup. In a particular building. So as I said, you know, maybe 80 floors apart from those down on the ground who know that your life's in danger when you're up, but you can't communicate between each other.
Yeah, I can't say that this is a scenario that I've looked at too much. My focus really at the moment has been how the public calls into these environments rather than the first responder side.
Yep.
Obviously, we are going to have to look at how we bring first responders in. And I know that our product, for example, has got a number of ways that we can link in third parties in a secure fashion. But again, those are looking at relatively reliable communication links rather than the situations where your underlying infrastructure has kind of disappeared.
Yeah, there's two things, like on site. One of the things I'm seeing is self-healing mesh networks where every responder essentially is a node. And as they move around, they just the network keeps building itself. And then the other thing, and this is something that we're seeing more and more here, especially in the area where there's wildfires, that the tower may exist. However, the fiber in the ground for backhaul melts. And now all of a sudden you've had isolation. And to James' point, it's that, you know, first mile, if you're the caller, it's the last mile if you're the receiver. If that doesn't exist, it doesn't matter how good the system is or how redundant, how much redundancy is built in. Isolation is isolation.
Thank you so much, James. This was really interesting. In the interest of time, we'll move on now to the next speaker. So our next speaker is Dr. Silvio Scornavaca, who will be talking to us about location-based stakeholders. Dr. Scornavaca is a professor at the School for the Future of Innovation and Society, in the College of Global Futures, and Thunderbird School of Management at Arizona State University. Prior to joining ASU, Professor Scornavaca was a Parsons Professor of Digital Innovation and Director of the Center for Digital Communication, Commerce, and Culture at the University of Baltimore. Silvio is a global scholar with strong research collaboration across 6 continents. Very impressive. He's held visiting positions in Japan, China, Egypt, Italy, France, Finland, Spain, New Zealand. Are there more countries? Brazil, Morocco. His research interest includes disruptive digital innovation, high impact innovation, digital entrepreneurship, ICT for development, digital ecosystems, And during the past 20 years, he has conducted multidisciplinary research using qualitative and quantitative methods in a wide range of industries, including research sponsored by the private sector. He's held several editorial positions and served as a track chair at leading conferences. Thank you so much for being here today with us, and thank you so much for sharing your knowledge with us. The floor is all yours, Dr. Skurnavak.
Thank you, Salah, and it's a pleasure to finally be here in Arizona. Thank you again, Katina, for the invitation. So when we think about location-based services, this, funny enough, takes me back to a meeting at the first mobility roundtable in Tokyo in 2001, when the idea of time, space, and interaction could be captured by mobile devices. And the key element here that we think about is about value creation. So from a company perspective, so my view here is, I was teasing Katina yesterday that I'll do the good and she'll do the bad and the ugly. And when you think about from the company perspective, when you are able to capture context, so basically you're looking at the temporal and the spatial dimensions of any kind of interaction that you have with your customer, that brings a superb amount of value. For example, if you look from the applications in marketing, the idea that you can also control and understand not only what message you're sending and to whom you're sending this message, but also when and where that message is going to be delivered. That also increases the possibilities of return on investment on any marketing initiative that you're doing. So from the company perspective, it brings a much more refined understanding of how your customer behave in the context of time and space. But at the same time, it brings an amazing, those two variables bring an amazing value in terms of how can you also manipulate through pervasive and persuasive technologies certain behavior. So how can you actually reach or deliver a better service, but at the same time, reach with more accuracy the wallets of your customers. The problems with this is that it brings actually two main paradoxes. One is in terms of value creation and value appropriation. So if you think about by providing your data to a company, so for example, Salah here, I can see he likes ice cream sundaes, right? Especially on sunny days. Yeah, you look like an ice cream sundae kind of guy. And you know, so for him to say, I'll give my data to, I don't know, for an ice cream shop, that when I'm around there, it may send me a message, you know, buy one, get one free, or get, you know, extra toppings and things like that. So he, as a consumer, he can see that changing that, you know, providing that context of time and space where he is and when he is, bring him the value that he may be able to get more customized or more valuable promotions or information. Now, the question is, how much value is actually Salah providing to the company versus how much value he's actually getting from the company? So that's the interesting bit there, that the ratio of value creation and value appropriation, it's not very fair if you think about, especially when you have, by the nature of digital, you have a high level of convergency in terms of, you know, almost a monopoly to a half a dozen of operators about where and when people are. The other issue here is that the value that, or things, or that can be valuable for the user, not necessarily are valuable for the company, and vice versa. So you have another level of a paradox here, that is this dichotomy between what is interested for the organization versus what is interested for the user. So when you think about, and you know, to make sure we have time for Katina to go more on the bad and the ugly, from a company perspective, knowing who you are, when you are, and what you are, and when you are, what you are, who you are, and what are you doing, it brings an amazing amount of detail of information that you can produce very powerful marketing messages from that. So it certainly brings a whole new level of, pervasiveness or interaction with your user. However, all this doesn't come for free. And the question that I would like to leave here is, the benefits that we are getting for providing our temporal spatial information are fair in terms of the risks that we assume by giving that information away. Thank you.
James referred to the ability to continually pack our technologies with new sensors. In fact, old CCTV cameras can actually have firmware updated, and even if their resolution is low, they can actually do things like biometric matching just by the firmware, the software being updated in the hardware itself. What that then does is give us an IP location, because that is a node on a network somewhere, and it allows that location, though it's a fixed location, to be married up with location information. If you corroborate that with mobile data, what you have is mobile CCTV capable of doing biometric recognition. And that's where some of the push and pull factors, perhaps, for example, in retail stores, when you enter and there's a device there that can see you, becomes an issue. In the breakouts that we're going to go into now, we're going to use Jamboard. I've posted 2. Melissa, I'm going to ask you to break us into 2 groups. One will be Martin's group, the other will be Farah's group. And in that group, we'll try to unpack what James was talking about today. And also to look at the question of, as Salah and Eusebio noted, almost like the good parts in terms of safety of location-based services and biometric recognition, for example, knowing who you are and what condition perhaps you're suffering with or living with. And then the flip side, which is how location services may be exploited by retail stores, for example, or by other location and biometric recognition systems. So we'll go into those breakouts now, and over to Martin in breakout room 1 and Farah in breakout room 2.
Yeah, I just want to give both groups the opportunity to give their remarks. I think we had a very interesting discussion, and I'll just to respect everyone's time. I would like to ask Martin's group to start off with just some closing comments, and after that, Farah will follow for her group. If you have anyone selected that will present, please go ahead.
Well, we didn't define somebody to present. We were like really excited on the diversion convergence, but like we get approximately like 20-25 posits distributed in 5 categories that are values, maintenance, justice, capabilities, and design issues. I will like highlight that the categories capabilities is full of questions that these kind of systems are emerging.
So the number of the post-it notes were just unbelievable on your side. So that's really great. Yeah, there you go. Absolutely fantastic.
Okay, so our dashboard doesn't look as fancy as STS, as Martin's, but I know I can tell if Martin's printing there. So our group had a very rich conversation on questions of, for example, the awareness of those that generate data, the awareness on the economic value of who owns the data. So that means that users, and the awareness on where the data is stored, who owns that, and how this generates economic value. Then there was a discussion on different systemic inequalities and a question on the consent of, so given this location, enabling these location services and algorithm bias. Like there was a case brought on for the COVID pandemic and the access to the vaccine, the need to access a mobile phone to schedule vaccine, and an automobile in the case of Brazil, but also nursing nursing houses in the United States being left out as part of like the response and planning for the pandemic. And the other was, I think Elma brought this also on in the recent flood in Germany, and also a nursing home being left out. Even there is like data on where these people are located. The question of, again, consenting to these services is when is it a consent a person gives, and when is a need or a trade-off that they have to. And the example that I'm referring to was brought on homelessness, on unhoused people who can have a mobile phone, but to access certain social services, health services, or to shelters, there might be some tracking of their location involved through their cell phone. So in this case, the consent is traded maybe to access others. So what are the implications of this? And what is this? And I feel that that's all, but I don't know if the group wants to raise. Have I missed something? Sarah, Eusebio, Elma.
I just want to add one more thing before we go to closing. Okay. Lee, please join us next time. I think your views were very interesting, and I feel like you know, the including the discussion about people who live outside is very important, because that's obviously, you know, it's not, you see, you added a lot of value there, and I think it's very important. Me being in Silicon Valley in San Francisco, seeing it outside in the middle of the tech industry, it just doesn't make sense that we don't talk about this a little bit more. So please join us for our future discussions. Love to hear more from you.
Thank you. I found out about this because of Katina's LinkedIn post. If somebody could drop me, if this is a regular thing, if somebody could drop me a meeting invite with the pattern, you know, if I have a meeting for my day job, I'm in the Pacific time zone, so I could easily have a meeting for my day job, but otherwise I would love to. Yeah.
Thank you so much.
Mm-hmm.
I know that Satija will reach out to the students. He will reach out to, if he reaches out to me, I'll make sure that his message will be sent across. I would like to thank everyone before we close. Thank you for your time. Thank you for sharing all of this knowledge. It's just been amazing. See what an hour and a half can do. This is just great.
So we look forward to sending that email out to you, Lee. And friends, thanks for coming to the first one of Series 2.
Absolutely. Thank you so much.
And thank you to Salah and to the facilitators and to the speakers and participants. Bye for now.
Thanks, everyone. See you then.